Quantum mechanics shows us that particles like photons, electrons, and even atoms are in superposition, meaning they can exist in different states and even multiple places at the same time. They are thought to be nothing more than waves of probabilities until the moment that they are measured. This measurement collapses the probability wave of the particle such that it then becomes a distinct particle with distinct properties. One interpretation of this phenomenon is that the measurement being made requires a measurer or a conscious observer. If this is correct, then it implies that consciousness has to be an integral part of creating the world that we observe. Could this consciousness then be required for creating reality? Does this mean that there would be no reality without consciousness, implying the universe would not exist unless there was someone to observe it? The answer to this profound question is coming up right now. Experiments can show that what we think of as particles, like electrons and atoms, actually behave like waves, waves of probabilities. This is the foundation of quantum mechanics. The famous double-slit experiment illustrates this. So for example, if you shoot single atoms through two slits with a detection screen on the other side, and you do this repeatedly, these single atoms do not show a pattern like individual particles would, that is, two bands of particles. Rather, they show an interference pattern, like a wave, similar to the pattern that a wave of water would make if going through two slits. This means that the particle going through the slit is either interacting with itself or other particles that are about to be fired but haven't gone through the slits yet. Okay, so this may be a bit weird, but most people can probably accept it, that atoms behave like ocean waves instead of like balls. But what is truly bizarre and unbelievable is that when you try to find out what's going on at the slits by placing a detector there to see what's happening with the atoms, by the way, this is called the which-way information. In other words, if you try to detect or observe the trajectory of these atoms, they all of a sudden stop behaving like waves and now behave like particles. And this can be recorded on the screen behind the slits. You might say, well, maybe the detectors are messing with the flow of atoms somehow. Maybe when photons bounce off the atoms and go into the detector, they disturb the atom and collapse its probability wave. But if you keep the detectors there, but turn them off so that no measurement actually gets made, the screen again shows an interference pattern. And as soon as you turn the detectors back on, the interference pattern goes away. So what's going on? Why do atoms and other particles behave this way? There are many interpretations of this phenomenon. The most widely accepted interpretation is called the Copenhagen interpretation, which was devised in 1925 by two pioneers of quantum mechanics, Niels Bohr and Werner Heisenberg, at the University of Copenhagen. Their theory proposes that the atom, when it is not measured, is not distinct. It is a wave of probabilities, meaning it can potentially be at various places at the same time with various properties. Each of these places and properties has a probability associated with it. That's why there's a probability wave pattern for these particles. However, as soon as the particle is measured, this probability wave collapses and it becomes a distinct particle with distinct properties and position. But the Copenhagen interpretation does not say anything about consciousness. It just says that the particle becomes distinct when it is measured. But what is measurement after all? Does measurement take place at the instrument that measures it? Does it take place when the instrument's measurement is recorded in its digital memory? Does it take place when a human eye sees the results? Does it take place when my brain interprets the result? Or does it happen somewhere in between? Does measurement necessarily require consciousness? This is called the measurement problem of quantum mechanics. The problem is we don't know, and this has been debated for years. Physicists do not universally agree on a resolution to this problem, so there are various interpretations. Another such interpretation is called the von Neumann-Wigner interpretation. This basically postulates that in the long chain of measurement, the collapse occurs at the moment that a consciousness, presumably human consciousness, interprets the measurement. In other words, the consciousness of the physicist is making the particle distinct, and without this consciousness, the atom would just be a wave of probabilities. But this raises all kinds of potential questions about what constitutes consciousness and how is it involved in this process. Can the consciousness of a lizard or worm also collapse We know that measurement that records the which way information of a particle indeed collapses a particle's uncertainty wave. There's no way to cheat on this either. It doesn't matter if we put the detector before the particle enters the slit or whether we put it after the particle enters the slit. This particle collapse is consistent forward or backward in time as well, as shown by the delayed choice quantum eraser experiment, which you can read more about through the link in the description. In other words, if we try to measure the particle after it has already entered the slit, presumably after any decision to collapse or not collapse should have been made, it doesn't matter. The particle seemingly is immune to the forward or backward trajectory of time. We cannot cheat and look to see what happened before we think a collapse is going to happen. As for the many worlds, the equations of quantum mechanics allow it to be true.
In this video, I'm going to show you how scientists can not only undo that effect, but how it's related to time. Let's take a look, shall we? So we're about to tackle a very tricky concept in physics, which involves the nature of space and time and whether the future can affect the past. But this is so tricky, I think it would be best if you viewed my earlier slits leaves an interference pattern, which means the photon is a wave. If we looked at which slit the photon goes through, we see a pattern that is consistent with the photon being a particle. We call the second experiment a which way study. This result is pretty freaky. Back in the 1930s, physicists like Niels Bohr speculated that human consciousness changed the result. The delayed choice and quantum eraser experiment. The simple and sadly unsatisfying answer is we don't know. However, I have given a ton of links to other descriptions of the delayed quantum eraser experiment that you can find in the description. Okay, so what's the answer? Like I said, we don't know. Could it be that the universe at the quantum level doesn't understand time in the way that we do? Is the universe super deterministic, which means that everything we do, past and future, is predetermined? Or getting even sillier, maybe the delayed quantum eraser experiment is just a bug fix in our simulation